Yeah, hi everyone. Thanks for having me here. I'm very excited to be here today. Two reasons. One is Pioneers was, or so far has been a really great festival. And the other one is, actually, I don't have a clicker to advance my slides. I don't know whether anyone can get me that. OK, in the meantime, actually, perfect. That's what I need. Green is forward. Thank you. OK. The other reason why I'm excited to be here is I'm a co-founder and president of a company called Anki. We're a robotics company located in San Francisco. And we are building robotics consumer products right at the intersection of toys and video games. And I moved to the US about 9 years ago. But before I moved there, I actually lived right here, not in the Hofburg, but close by. And so I studied computer science at the Technical University in Vienna. And those are sort of the three places I mostly hung out when I lived here. One was close to the Pilgrimgasse U4 subway station where I used to live, the library of the Technical University. And then it turned out I worked a lot in the Schönbrunner Schlosspark. And so those were sort of the three main things which stuck with me. And I actually went back yesterday to the Schönbrunner Schlosspark, and so it's very exciting to be here. I just want to give you a very quick overview of what the company is and what we're doing, but I'm going to keep it to just one slide because you can look this stuff up online, and later I want to go a little bit into the details of the technology behind robotics in consumer products. So just very quickly, we're located in San Francisco. We launched our first product called Anki Drive. It's a robotic car racing game. So it's a video game, but you play it with actual physical cars. And we're going to do a demo on stage in a little bit. The whole thing got kicked off about 1.5 years ago when we got introduced at the main stage at WWDC by Apple. We worked fairly closely with them. On the bottom right, you see a picture of one of my co-founders with Tim Cook on stage. So before then, pretty much nobody knew about us. And then since then, we just had an absolutely incredible 1.5 years. We raised, as you heard, a fairly large sum of funding. 3 years ago, we were 4 people. Now we're 72 people. And last but not least, we launched our first product. And since about 1 year, got really, really phenomenal feedback about the product. So it got voted top 25 inventions of 2013 by Times Magazine and so forth. And even better, we're getting really, really great reviews on Amazon, Apple.com, and so forth. So I want to tell you just very, very briefly about why this is robotics and what robotics in consumer products really means. So my co-founders and I met during the PhD program at Carnegie Mellon University in Pittsburgh. And when we were there, we usually worked on really, really big robotic systems. And big meaning both a huge amount of funding and also physically big and very, very complex. But we worked on crazy things like wall-climbing robots, self-driving cars, or something like remote bomb disposal. But one of the things which all of those robotic systems had in common is that they were mainly constrained to a lab, and then there was like a demo day, maybe like 8 months out or so, and then everyone worked towards that demo day. And the whole thing works really well, or hopefully well, during the demo day. But if you show up a day before or a day later, it will probably not work. But very, very advanced technology and very, very expensive technology. And we got very, very interested. I'm going to go back one time. We got very interested in trying to figure out how to use robotics in consumer products, in something which everybody, you and I, can go and buy in a retail store. So it can't cost more than a few $100s. But the question was really, which industries can we have a really, really big impact in, but still making sure that the whole thing isn't becoming extremely expensive. And so turns out robotics applies to many different industries, and we had to choose one. And we started right at this intersection of toys and video games. And there is a very good reason for that. So one is we were all huge car fans, and we were all big video game players. And we noticed that there is a really, really big gap between physical toys and video games. So if you, there is some sort of attachment which people have to physical real things, to whether it's teddy bears or dolls or so. But if you look at physical toys today, toy cars or anything like that, they are pretty much the same or almost the same as they were 30 years ago. If you look at doll or at a doll, a ball, cars or so, you find a little bit of electronics here and there today, but the play patterns are pretty much exactly the same as they were 30 years ago. On the other hand, if you look at video games from 30 years ago and from today, they have pretty much nothing in common with each other anymore. Who here is old enough to remember a video game called Pong? Anyone remember? Oh, OK, so a fair amount of people remember this. So that was released. It was one of the first video games ever released, the first one which became really famous. It was released in 1972. And if you look at video games today, they have pretty much nothing in common anymore with video games from back then. Things like Assassin's Creed, Madden Football, or Need for Speed. The video game industry has been notoriously good at making use of new technologies. They started out with very, very little computational power. Then computers got faster, graphics got better. Then at some point, the internet came along, and one of the first things or first industries ever really making use of connected computers was the video game industry. Then later, mobile came along. Video games immediately jumped onto that. So in contrast, the toy industry has been extremely bad at adopting new technologies, and that explains a little bit this gap between the two industries. So we felt like we have the tools in robotics to apply the things we really, really love about video games, but apply them to real physical toys. And the reason why that is important is because people or kids love toys, but they don't play with them for just like an incredible amount of time. When you look at certain video games, people play for hours and hours and hours. And the question was, can we use some of the fundamental things inside of video games and apply them to real physical toys? And that's where the robotics part comes in. So once we decided that that's an industry we're very interested starting out with, we had to dissect the problem and figure out how we're going to solve something like this. And as it turns out, it doesn't matter what kind of robotic application you're actually creating. The implementation changes, but there are three fundamental things in pretty much any robotic application you have to solve on the technology side to create a smart robot. And we call them positioning, reasoning, and execution. And I'll explain a little bit on what those are, how they're implemented in something like our first product we're going to demo in a few minutes, and then how they transfer into other industries. So I'm going to start with the positioning part, which is the most fundamental one. So positioning means that every single robot needs to know exactly where it is located in its environment. In the case of Anki Drive, we have little robotic race cars, and they need to know where they are located. They need to know where the other cars are located. Their environment is a racetrack, and only if they know where they are and they know where everything else is around them, then they can start doing really clever things. That's a really, really fundamental idea, and it's true for no matter whether you're building, I don't know, a coordinated swarm of drones, or you build a self-driving cars, or you build something like Anki Drive, you will find this need for positioning in robotics, sometimes called localization, everywhere. And so that's the positioning part. The car knows where it is. It knows where the other cars are located. So imagine, it's even true for all of us. Imagine you want to play a game of tag with your friends, and somebody blindfolds you. That makes it pretty much impossible to play tag. But if you take that blindfold off, then it becomes very, very reasonable to play tag. And that's no different for a robotic system. Once you know where you are and everything interesting is around you, then you can start doing something clever. So that's the first step. The second one is what we call reasoning, and that's built on top of the first step. What that means is, once you know where everything is located, then you start to make a plan. And in the case of Anki Drive, a plan might be, I'm a car, and should I speed up right now and pass another car on the right side, or should I slow down and hang back a little bit that I can shoot at the car when it's in front of me, or should I pass through two cars in between and speed around the curve so that they can't shoot at me. In the case of Anki Drive, the AI, which is running on mobile phones, is making on the order of a few thousand decisions like that per second, trying to figure out what those cars should be doing next. So that's the reasoning step. And the last one, also very important, is what we call execution. And what that means is, once you have a plan, then you got to figure out how to execute that plan precisely. And it's very important that you're executing that plan precisely, because if you don't, you need to do what we call replanning. So imagine the AI tells a car, you drive 5 centimeters over to the right side, and then you have to speed up to, I don't know, 5 meters per second. If the car doesn't actually do that, then it will end up in a different location than what the AI thought, and then the AI needs to make a new plan. So the more precise you are at executing, the better the planning step will work. So that's the execution part, and I'll talk about this in a second here, but the beautiful thing about this is once we have those three things, positioning, reasoning, and execution, then we can do something very powerful. And that's, we can now abstract away the real world and treat those characters, those cars, just like as if they were characters in a video game. And we can use the last 20 years of software development and research, which went into trying to figure out how to make good video games, but apply them to real physical things. That's where the robotics part comes in. And the other beautiful thing is, as I mentioned before, you find those three problems, position, reasoning, and execution, in pretty much any robotics application wherever you have a smart robot. Not if you want to just remote control something, but if the robot's supposed to be clever, then you will find those three things everywhere. So this technology transfers extremely well into other industries. The implementation might be different, but the highest level concepts are exactly the same. And speaking of implementation, I'll show you just very quickly what's inside an Anki Drive car, because it's rather complex. So each car has a camera inside, not unlike the front-facing camera you'll find in your iPhones. It's programmed in a very different way, though. So instead of taking pictures or video at, like, I don't know, 30 frames a second, the car looks at the track 500 times per second, trying to figure out the exact location of the car on the track. That's combined with a custom lens projector system to make sure the image we get back is a very good image. Then we have something called optical encoders, which tell us exactly how quickly the wheels are spinning. And then the whole thing is driven completely by software, and that's very important. The hardware can stay the same through the entire ecosystem, but the software defines the entire behavior of the cars. This is running on a 48 megahertz processor, which a few years ago cost probably on the order of like $50 or so. Right now at volume, you can buy something like this for 80 cents. So this drop in component prices, not just true for the microprocessor, but also for the cameras and so forth, mainly driven by cell phones, is a huge, huge deal and allows us to do the kind of things we're doing. And then I mentioned the software to give you an idea. Each Anki Drive car, they're about 8 centimeters long, you'll see them later, has approximately 28,000 lines of code driving the cars. And the reason for that is that the sensors need to be low cost. They have to deal with a lot, the software needs to deal with a lot of noise, so you have to make up for low-cost components by writing incredibly smart software to deal with those components. And this is only the code running on each car. This doesn't count for the code running on the phones, which is a multiple of the code running on the cars. Cool. So this was it on the technology side, and I think we're going to do a demo now. To just show you how Anki Drive works and what it really is. And then after that, I want to show you a few numbers which we didn't show yet publicly. So they're very interesting just to show what can happen if you release a product like this into the wild. So yeah, let's do a demo. Somebody's going to come and help out. And we're going to, I think, pick somebody from the audience. Perfect. Are you going to pick somebody?
Yes.
Perfect.
Now, who would like to volunteer and have a little race on stage? Raise your hand now. Who would you like? Anyone?
You pick. You pick.
The first person who jumps up gets it. You got it. I'm sorry, that was the most spontaneous one. I'm sorry. Make some noise for him. And don't forget. Hello.
Hi. Hey.
Don't forget,
What's your name?
if you have questions.
John. Hey, nice to meet you.
use Slido. We will be answering them shortly, so go for it. Use Slido. It's in your app. Just scroll to the right. You'll have it.
Perfect.
Goody.
Yeah. So we're going to do a live demo. You're going to play too?
Yes,
Perfect.
gladly.
Okay. So I love live demos, especially when they involve multiple wireless things, because what could go wrong?
Nothing. It'll be fine. You're brave. That's good. It's always a good sign. You're confident in your product. It looks awesome.
I think it's going to work.
That's always the magic word. This probably is going to maybe work. No, we're confident. Like my inner 5-year-old is going bonkers looking at this.
Cool.
It's great.
So what he's doing right now, can you see this on screen? Okay. So what he's doing right now is he's using multiple phones to connect to the cars. They use a technology called Bluetooth Low Energy. So there's very, very little setup process. And what happens is we're going to do a race with 4 cars. Where 3 of us, or the 3 of them are going to play a race, but we're going to add 1 AI car. And what that means is that that car is going to be completely driving itself, and it's going to race against us. That's something which you find in a lot of different video games where you can play against completely computer-controlled characters, but it's completely absent in something like physical toys. And as I mentioned earlier, this robotics under the hood really allows us to do some of the things which you normally only see in video games. So I'm actually going to take the AI car off first because it's going to be very good. And then we're going to train a little bit, and then we'll show you what happens when you race against something like the AI car.
Don't forget, you can ask questions via Slido.
OK, so you guys are going to play,
Mega.
and I'll try to comment. So red is the AI car. OK, can I take this one? OK, cool. So I took off the AI car. So what we're going to do now is there's 3 cars on the track right now, and they're going to start what's called battle mode. So what that means is you don't win by completing a certain number of laps, but you win by shooting other cars off the track. So guys, if you can wait 1 second and don't do anything with your phones for a second, just wait. So what you can see is the guys are not doing anything, but the cars are still driving on the track. So they are staying on the track on their own. So that makes it very, very easy to start out. But as you get better, the cars get better as well. Right now they're driving rather slow, but as you speed up and as you advance, the cars get faster and faster. And so the game is going to keep challenging you for a very, very long period of time. OK, so now you guys, how about you start, and try to shoot each other off the road. So what they have is on the left side, they have a slider which they can slide up and down to change the speed of the cars. And if they tilt the phone to the left or the right side, the cars are going to steer to the left and the right. But even if you don't do that, they will still stay on the track. And then on the top right, they have a special item, in most cases some sort of weapon, where they can shoot at other cars. And the goal is to shoot the cars off the road. Nice. OK. So did you guys get a little bit, did you get a hang of it?
It's
so nice. Fun. So he just got shot. Nice. Who's yellow? You're yellow? Oh, nice.
Okay. Myself, yeah.
Perfect. OK.
That was awesome.
So you see the collisions. That happens all the time. So this is an AI car. I'm going to put that car on the track now, and it's going to drive. Look out for the red and black car. It's going to drive completely on its own, and let's see how good the AI car is. They got a little bit of a head start and get some points, but let's just see how it goes. So I'm going to take the car. I'm actually going to put it on the track reverse way so that you can see what happens in that case. Let's see. Here we go. Okay. So the car will start driving, but it will at some point figure out it's going the wrong way, and it will flip 180 and then drive the right way. So the AI car is driving right now, and as you can see, it already got somebody off the track. I believe, is the car set to medium or easy or hard right now? Hey, Dorian? Yeah. Is the car set to what level right now?
It was easy.
Easy, OK. So the AI car is set to easy, so we'll see who wins. Especially when it's medium. You saw the car just bumped off the road, but found its way back onto the track.
I shot you.
That wasn't a deal.
Very cool.
That was good, huh?
So what you see up there is you see the phone screen, and you see that he's right now in second place. I think this is Dorian's screen. So he's in second place right now. Every time he gets shot, you see how other people get points, and when he shoots at somebody, then he gets points. And those points you can use after the race to upgrade your cars. So the more points you have, the more special items and so forth, like turbo boosts and so forth, you can get in the app and upgrade your cars. And then at some point, you're probably at a level where you change the AI car from easy to medium and then to hard. And at hard, it's very, very hard to beat the AI car. Very few people are actually able to do that.
Oh, yeah.
Very
it's a bit
cool.
like Formula 1, isn't it?
Oh, the AI car just went off the road.
So you've got robots driving cars.
Is it a race to how long? How many?
5 points.
5 points. Okay, cool.
Just finished it.
Yep. Oh, it just finished. Okay. So the AI car just won the race, even though it was set to easy, but those guys played for the very first time, so it's a little bit unfair. It's also, this track is a slightly more advanced track, so it's a much better idea to start out with the track which comes in the base kit and then get something like this later on, because the intersection, that cross you see in the middle, is actually pretty hard to deal with, and you need to still learn how it works. The AI car, however, knows about something like the intersection track, and the moment you put it on the track, it will make full use of it, meaning it will slow down before the intersection and wait for you to drive by and then shoot you off the track and things like that. And as a person, you can do the same thing, but you still need to learn how it actually works. Cool. Okay?
Thank you.
Perfect. How are we on time? I don't see a timer, so I don't know how we're on time.
There's your timer.
Huh? Ah, okay, perfect. Okay. Okay, perfect. So we have a few more minutes.
And then we'll do the Q&A?
Huh?
Q&A then?
Yeah, I'll go through 2 more slides and then we're good to go. Cool. Okay, so this was the live demo. It worked. And let's see whether I can move to the next slide. I'll skip over this. That was my backup video in case the demo doesn't work. So now that you've seen how the product itself works, check out online what people think about the product. It's very, very interesting. And now I just want to show you what happened over the last approximately 12 months in terms of data. And this is interesting for 2 reasons. One is just to see the actual data, and the other one is the fact that we have that data. So I'll show you a few things. Over the last 12 months, Anki drive cars have driven a total of over 120 million laps. What that means in distance is, in kilometers, it's a little over 550,000 kilometers, which is approximately 14 times around the globe, or from here, the Hofburg, to the moon and halfway back. And that's all driven by cars which are about 8 centimeters long. And the last number, and that's, as a robotics geek, that's one of the most exciting ones for me, is the total number of decisions the artificial intelligence made during actual races. And those are not races in our lab or so. Those are races in people's homes for people who have bought the product, was approximately 11.9 trillion. So what that means is 11.9 trillion times the AI made it running on mobile phones, made decisions which then resulted in an actual physical action of a small robotic car in people's homes. And in most cases, it probably worked. So that is something which is, I think, completely novel to consumer products. So having that sort of sophisticated robotics and AI running in a consumer product, which then controls a physical object, is something which just completely otherwise doesn't exist. And as I mentioned, those things transfer really, really well into other industries. The implementation might change, but those things I mentioned before, positioning, reasoning, execution, they transfer into other industries very, very well. And let's see, I have about 4 minutes left. So I didn't know exactly how long the demo is going to take, but I'm going to just talk very briefly about a few. This has nothing to do with the product or so. This is just, I thought, something which might be interesting for some of you guys. Some of the most important lessons we learned over the last few years while running a VC-funded consumer products company. The first one is, and this is not true for everybody, but it was definitely true for us, is proof of concept comes before incorporation and before funding. What that meant is, We started in grad school before we had any money. I remember we had board meetings where the three of us decided whether we should invest another $300 out of our student loans into the company. So there was literally no funding. But we spent a lot of nights and weekends proving the technology, because if you're trying to raise venture capital, it takes a lot of time and it's a lot of effort. So if you can, especially when what you're trying to create takes a certain amount of time to implement, you can, in some cases, save yourself a lot of headaches by not being full-time in the beginning, but doing it at nights, doing it over weekends and so forth, and then just showing up to investors later and show already functioning demo. And because the technology is complicated, it took us multiple years during grad school to get to that point. So one of our investors actually said many entrepreneurs are made on nights and weekends, and that's, I think, very, very true. The other one is, and it's almost a cliche, but it's very important, so I want to stress it again, is hire only incredibly good people. It's that is pretty much one of the most fundamental things you need to do. You can't hire people who are average at what they do. They need to be really, really phenomenal. Otherwise, you might never get to the point where you actually need to go. And we did two things, I think, really well at Anki, trying to implement something like this. And that is, one, keep a list and start it now. So even when we were in grad school, my co-founders and I, we kept very meticulous lists of all the amazing people we encountered and thought, hey, at some point, if we ever start a company, those people might be perfect to work with us. And one step beyond that, before we ever raised our Series A, we actually went to a bunch of those people and told them, hey, in a few months from now, we're going to be raising a Series A, and the moment we do, you have to quit your jobs and you have to come and work for us. And the coolest thing was most of them said yes. And so what we did is when we showed up to our VC meetings, we didn't just have a functioning demo and a good plan of what we're going to do, but we also said if we raise this money, here are the first 6, 8, 10 people who are going to be helping us to implement this vision, and that has worked out really well, and I think it was pretty impressive. So that's very important. And the other one is, and it's slightly related, is build an advisor network, and that's something which I completely didn't realize before we started the company. And it's so important that I actually made it into a separate point. Spend time and effort to build an advisor network, because not everybody needs to be full-time. And having a really, really strong network of advisors who are taking your phone call from time to time is really, really important, not just for hiring, but for pretty much everything. And I'll give you one example, and I have 22 seconds, so let's do this quickly. I'll give you one example on how that worked out for us. So our head of industrial design is a guy called Harold Belker, originally German, but lives in the US, and he is a very, very famous Hollywood movie designer. He designed cars, all the cars for movies like Minority Report, Total Recall. He designed the Iron Man face mask. He designed the early versions of the Tron light cycle and so forth. And so I had no idea who that guy is. I just noticed that when I looked through concept car designs that his designs somehow stood out. And so I really wanted to talk to him, but I had no idea how to get in touch with him. So I sent one of our advisors, who is very well connected in Hollywood, an email and said, hey, there's this guy, Harold Belker. Do you know him? And he wrote back right away and said, I don't know him, but a friend of mine directed Minority Report. Let me see what we can do. And then literally like 2 hours later, I get an email which said, hey, Harold would love to talk to you tomorrow at 9 a.m. So that was a Thursday evening. Friday morning at 9 a.m. 2 years ago, I talked for the first time to Harold. And then my co-founder and I drove down to LA, met Harold. We got along really well. And since about 2 years, he's full-time with Anki. There is no way that we could have pulled something like that off without really phenomenal advisors. And this is just one example, hiring related, but it's, I think, a very, very important point overall. Cool. So I'm completely out of time, so I'm going to skip over the last one. And I think we're going to do some form of Q&A right now.
That's right.
Cool.
Excuse me, sir.
And
don't worry. Take your time.
If you have any questions or so after the Q&A, feel free. I love to chat, so just grab me somewhere and feel free to ask anything.
I've selected the first question.
Okay, perfect.
And I love it. It's shut up and take my money. Where can I buy how much? That's down to the point.
Is it the product or the company? Okay.
Both.
Only the products for sale. Cool. So you can buy. I didn't want to talk too much about the product itself, but right now we're only selling in the US and in Canada and in the UK. Last year we launched exclusively with Apple, so we were in all Apple stores. This year we're in over 2,000 different doors. Apple stores, Best Buys, Toys R Us, on Amazon of course, GameStops and so forth. And we are not selling in Europe yet, but it will come soon.
Yeah, but how much, like roughly?
How much does it cost?
Yeah.
Okay, good question. Yeah. So the base kit costs $149 US. We actually started out at $199 a year ago because we had to. But as I mentioned earlier, no component prices are dropping, and our goal is to really make this as affordable as we can. So just a few weeks ago, we were able to reduce the price to $149, and that's, I think, pretty phenomenal. So,
you got any hidden in your booth we can buy today?
Sorry, say it again?
Any hidden here?
I don't believe we're selling, no.
Nah, come on. One or two. Okay, fair enough. This is a good question. How did you manage to score the presentation at Apple's keynote?
Yep, good question. Very good question. I mentioned the whole advisor thing earlier. This was sort of different. One of our board members actually got us in touch with Apple, but it had nothing to do with the keynote at all. It was more like, so we were using this technology called Bluetooth Low Energy, and we were using it in a very early on and in a very different way from anyone else. And we had issues where we didn't quite understand how this thing works. So we needed somebody at Apple, we felt like, who can help us with this. And so we asked our board member to make an introduction to Apple. Then at some point we met with the executive team, and they really loved it and said, we'll help you in any way we can. So we got in touch with the right people at Apple. And then at some point after they actually saw a demo, not unlike this one here, they said, hey, wouldn't it be cool to show this off at WWDC? And we obviously said, sure. Yeah.
That sounds quite easy.
Yeah, it was pretty. It was a lot of work, and but they were really, really phenomenal to work with. Yeah.
How about this one? Does the encoder track the pattern underneath the black roadway? How is the road transparent to the optical encoder?
Yep, good question. This is a very techy question. The encoders are actually not looking at the track at all. They are just measuring the speed of the wheels. What is looking at the track is the camera. And the camera is, as I said, a pretty standard camera, but there is an infrared light attached to it. So the track, the road, which looks black to you and I, turns out it's transparent in near infrared. This is a printing technology we developed over a few years. So the cars actually see right through the road, and they see a pattern underneath, and that pattern over time tells the cars where they're located.
Now we've got 1:20, so we'll make quick questions,
One or
short
two
answers. More. Okay, first is, I like this one. Holds the record, who's quicker, AI or human?
Who holds the record for best lap? AI or human? Good question. Also based on data, the AI set on heart still wins about 85% or so of all races ever played. The best player I've ever seen is actually one of our testers, Paul at Anki. He is incredibly good, and he can win against actually multiple AI cars.
But the AI is normally faster.
The AI is normally faster, but he's better. He's better than the AI. Yeah.
Then it was a quick question. What was the fourth lesson learned, the one you skipped?
What was the? I don't remember.
Which is the one you skipped? Don't worry. Okay.
What was the last one?
We can also answer in due time afterwards.
I'll remember it in a second.
Okay, fair enough. What else? Quick one is, are there bigger tracks?
Also a good question. The answer is no. There are right now no bigger tracks. And the reason is not that the cars can't deal with it. It's purely a logistics reason. No? When you sell a product like this, you have to put it in a retail shelf. And you have to somehow put it in a manageable box so that people can go and buy it. And the number two is, when people unroll the track, they need to have enough space in their houses. So we did a lot of research trying to figure out what's the biggest possible track we can make so that it still fits into a reasonable box, but people have enough space at home to play with it. So, and this is where we ended up with 8.5 by 3.5 feet. Yep.
Now I've got last question, we're over time already. What's your future pricing strategy? Will you charge for additional upgrades, bigger machine guns and stuff?
Yep, also good question. The answer is no. We're charging for hardware. All the upgrades are free. So as a matter of fact, one of the really cool things we can do is, based on that data we're getting back from gameplay, we know how people use the product, and we can iterate very, very quickly to make the game better. So over the last year, we had 3 major software updates with completely new game modes and so forth, which people can use. And they're obviously all free. So once you buy the product, you get all this stuff for free. And one of the biggest and most phenomenal updates is actually coming in a few weeks from now. Yep.
We'll be curious to learn that.
Okay.
Thank you so much, Hans.
Okay.
Thank you
Thanks
so
a
much,
lot.
Anki.
Hey.
Have a blast.
Thanks.
Thank you,
See
mate.
soon. Yeah.